Okay guys, so I'm up to section 8.2, objective number 4. I'm on pages 9 and 10 of the note packet. So now we're going to use technology to perform a t-test for the difference between two means, still in the situation of independent samples with sigma 1 and sigma 2 unknown and unequal. So if you remember the work we did in objective 3, we showed you those 9 formal steps in a 2-sample t-test. And what I'm going to now throw into the mix is that we can use our calculator for shortcuts, and that's going to be for steps 5, 6, and 7, where we will let the calculator calculate the t-test statistic, the degrees of freedom, and the p-value for the test. So here goes a new context in the example. If you read it with me, we have a manufacturer claiming that the calling range for its cordless phones is greater than for the leading competitor. So if we do a study with 14 randomly selected phones from the manufacturer and 16 randomly selected from the competitor, we look at the results in the table to see if we can support the claim from the manufacturer. All right, so if we work out the formal steps, number 1 is to just write down our verify steps, and in this chapter, section 8.2, the 2-sample t-test, we're starting out with random and independent samples. Then we move on to saying that the sigma 1 and sigma 2, remember those are standard deviations for the two populations. They're unknown and unequal. And finally, both populations are normal. Okay, after we do the verify step, step 2 is to write down the pair of hypotheses. Okay, so if you hear the claim being made, there's a manufacturer claiming that their cordless phones have a greater range than the competitor. So I'm hearing a claim that the mean for population 1 is greater than the mean for population 2. I'm going to write that down next to HA because of the inequality. And then the null is the complementary claim that mu1 is less than or equal to mu2. Step 3 is simply to state the alpha level for the test. It's 0.05. Step 4 is to write out our summary stats, but they're already in a table, so there's no need to make our own table. Step 5 is where we're going to calculate our test statistic. Step 6 is to write down the degrees of freedom. And step 7 is to put in the p-value. All right, so now we're going to have the calculator do this for us. So I'm going to go into stat tests, enter those 6 summary stats. Okay, so let me direct you to what I'm about to do. Following right here, stat tests, option 4, the 2-sample t-test. You're going to toggle to stats once you choose that option. And then you're going to enter 6 stats plus the format of HA, which has a greater than sign in it. And then there's going to be a question pooled to no or yes. The default is no. That's the 2 unequal population standard deviations. So we're leaving pooled on no for that. Okay, next thing to point out is that the degrees of freedom are actually quite complicated when software is used. We don't simply go to the smaller sample size and take away 1. We don't use 13 degrees of freedom. We're going to let the technology do a complicated formula for degrees of freedom. It provides a more accurate p-value. You wouldn't be responsible for this. We just have to write it down. Okay, so when I write down the degrees of freedom, I'm not going to write 13. I'm going to write the ones that come out of the calculator. So I'm going to pause. You guys pause as well. Do these things in your calculator, and then I'll be right back. Okay, so I'm back. My calculator just told me that the test statistic is 1.76. The degrees of freedom on my screen, if I round to 1 decimal place, it's 22.2. And the p-value, if I round to 4 decimal places like I would be doing in other chapters, it's 0.0458. Okay, so 5, 6, and 7, quickly done with the stat test menu in the calculator. Now I'm ready to work on step 8, which is the decision for the test. So since that 0.0458 is below the alpha level of 0.05, we make the decision to reject HO. And step 9 is the conclusion in context. So when you reject HO, phrase 1 is there is enough evidence. Phrase 2, because the claim's HA, we write to support the claim that. And now I'm going to be translating the HA claim into words. So if I direct you to what I'm doing here, the context of the problem, the wording said the mean range of the manufacturer's phones is greater than the mean range for the competitor phones. So I'm just going to communicate that in the decision down here to the test. So the mean range of the manufacturer's cordless phones is greater than the competitor. Running out of space, so there we go. All right, I have a second model problem on the next page, so let's go there. So if you'd like to try this, feel free to pause the video now and come back on to see if you've done it right. Now we have in this context a personnel director in Hawaii claiming that the mean household income is the same in Kauai County as in Maui County. So in Kauai County, a sample of 18 residents has a mean of blah, 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 standard deviation, blah. In the Maui County, same thing. So at alpha equals 10, can we reject the claim, assume the population variances are not equal? So let's do those 9 formal steps. Step 1, this doesn't change from problem to problem. We're writing random and independent samples. And then we write sigma 1 and sigma 2 are unknown and unequal. And then we write both populations normal. All right, step 2, the pair of hypotheses. All right, remember you have to be careful about this. Go back to the stem of the question, and you will see that the personnel director is claiming two means to be the same. So when we write our pair of hypotheses, I hear it claim that mu1 equals mu2, so this problem has HO as the claim. The complement then is mu1 not equal to mu2. Step 3, the alpha level, 0.10. Now step 4, they didn't make us a table of summary stats, so let's make our own. So since they mentioned Kauai first and Maui second, how do you spell these? M-A-U-I. There we go. So now I'll write X bar 1, S1, and N1, making my own table, and X bar 2, S2, and N2. So X bar 1 is for Kauai County, the mean household income at 56,900, the standard deviation at 12,100, and it says it was a random sample of 18 households. For Maui, we have 57,800 for the mean. We have 8,000 for standard deviation, and we had a sample of 20 households. Okay, guys, so we see roughly like a $900 household average income difference. So the job of the t-test, if you're understanding the big idea here, the job of the t-test is to see, statistically speaking, if these two things that differ by $900 are statistically significant. Is the $900 difference statistically significant? Okay, so I'm going to run the t-test in the calculator because I believe you will find these steps much easier in the calculator as well. That means steps 5, 6, and 7 can be shortcutted to writing down what the test statistic is, the degrees of freedom, those special ones that the calculator uses, and the p-value from the calculator. So I'm going to pause and calculate that stuff. Okay, I'm back. The test statistic, if I round to two places, was negative 0.27. The p-value, the degrees of freedom on my screen, it says 28.99. And the p-value on my screen is 0.7911. So it turns out that $900 average difference we saw from the sample data, totally not statistically significant. So since that 0.7911 p-value is greater than 0.10, we fail to reject HO. And then our sentence at the end is, there is not enough evidence to, remember we have an HO claim, so it's to reject the claim that the average household, I'm going to write HH, income in Kauai is the same as in Maui. All right, so that's section 8.2, objective number 4, running the t-test with our calculator shortcuts, but still displaying all 9 formal steps, which is the way I'd like to see it in your homework as well.